Hello everyone, welcome back to my channel. So in this video, we will be solving a lead code problem. So I'll tell how to tackle these kind of problem in actual interview and what questions you can ask around this problem. So let's begin. In this problem statement, basically you are given a root of a binary tree and we need to perform some operation like every time we need to collect all of the leaf nodes, then we need to remove them, and we need to repeat this process until the tree is empty. So in the given example, if you will see, for the first time initially we will have three nodes, node 4, node 5, node 3. After removing them, so the new leaf node will be 2. Once we will remove the leaf node 2, post that the new leaf node will be 1, and then once we will remove the leaf node 1, the tree becomes empty. So this will be our answer. So now let's go to move to the side like questions. What questions we can ask? So first of all, in real actual interview, it might be a case where interviewer is providing the problem statement, but they haven't provided this structure. So basically, if you will see, based on the structure definition, that this tree is binary tree. If they haven't mentioned it explicitly, then you can ask whether the given tree is binary tree or it can be a general tree because it depends on the input. So if the tree is binary tree, then your solution will be little bit different. Basically, your implementation will be different. And in case of general tree, then you need to modify your structure and post that your implementation as well. Yeah, so this can be one question you can ask. And guys, like please don't ask the constraints because it's irrelevant. If you will ask simply ask the constraints, they will ask you to solve on scale. So please directly think in terms of solution. Don't go on constraint side. So practice in such a way that you are unaware of the constraints and you need to solve it. So now let's discuss a few solutions. What we can do for to this to the problem statement. So this is the function we need to complete it. So let's go for the brute force first. So for brute force, what we can do? We can apply tree traversal algorithms. So there are few algorithms like BFS and DFS. So let's say we are taking the DFS approach. So for brute force, every time I'll apply a DFS from the root node, let's say one, and we will identify all of the leaf nodes. We will store those leaf nodes to our current result. Then we will simply remove them, and we will simultaneously we will repeat this process at every iteration. But this is the brute force. The complexity will be uh, n square here. N square is because every time we are iterating the complete tree and we are identifying the leaf node and then we are removing it. So in case if a tree is chain, a long chain, then every time you need to iterate each element and you will find a leaf node and you will remove it. So it will take any iteration, and in every iteration you are applying a DFS. So complexity will be n square. So this is the brute force approach. Of course, interviewer will not be happy with this solution. There are further optimization where we need to think of. So now we need to observe how we are going to do it. So if you'll see for this problem statement, so every time every new leaf node will have same depth from bottom. So if you'll see leaf node 4, 5, and 3 will have depth 1. 2 node has having depth 2, and node number 1 is having depth 3. So if I'm able to identify depth of each node from the bottom, then just the our result will be the concatenation of nodes based on their depth. So yeah, so this is a like good approach, and this can be solvable in single iteration. We need to just apply a BFS or DFS only a single time, and we need to calculate their depth, and post that we will store our answer. So this is a good approach. You can like guys try. So let's move to the implementation part. So so this is the function we need to return the list of list, or we can say vector of vector. So let's create a private function, uh, and basically we need a function to determine the depth of each node in a single DFS. So let's say we are calculating like depth. So yeah, so yeah, so the base case would be if this is null PTR, if the root is null PTR, this is the base case. We will simply return the depth as 0. Then we will call the left depth, which is again calling the calculating depth. Uh, Now simply we will calculate the right depth. Yeah, so what would be the depth of the current node? So the current depth will be max of left depth and right depth. Yeah. So yeah, now we need to store this node uh, with the like with their depth. So we need to decide a data structure, how we are going to organize our data. So I'm able to think of creating a map where the value of basically the key value of map will be the depth, and it will hold all of the nodes which are at the same depth. So we'll again our value will be again a list, or we can say vector. So let's call it store. So store will simply at will store the current node at their particular depth, and and this thing is denoting a list. So I'll simply update adding my current node to the end of uh, the list. So here we will be adding root well. Yeah. So if you'll see now this method is running over in time. So here we are calculating depth of each node, and we are storing it in some organized data. And now with this map, I will be able to calculate my answer. So first we need to call this function from the root itself. Now now I know the depth of node number 4, 5, and 3 will be 1, that the depth of 2 will be 2, depth of 1 will be 3. So this will be my map size. So basically we need to iterate depth from 1 starting till the depth size, basically map size. Yep. So now I need to calculate my result. So let's define the result. So result dot push back store of depth. So store of depth is storing all of the nodes at particular depth, which will be our answer. So let's run it. So we have found some error. We need to return the depth here for the parent node. It's a recursion. So every node will solve its result and will escalate their depth to its parent. Yep. So we are receiving the time limit. Let's see what's why it is showing time limit. Yep. Let's submit it. Yeah, so this solution is working very faster. Uh, so this is acceptable solution. It is taking if we'll discuss the complexity. Uh, so complexity here will be on and space. Basically, it is also on. So we are storing each node. So yeah, so this is acceptable solution. So now we have solved this question. So if you'll see, there are no follow-ups here in this problem statement. So interviewer might be can ask follow-up. So one follow-up will be I'm able to think of is like whenever we are removing the leaf node, so we need to consider the newest leaf node as compared to the old one. So for example, let's say I have removed leaf node 4, then leaf node 5. Now, if you'll see, the newest leaf node will be 2, which is newer than the leaf node 3. So I need to give priority to node number 2. Now, how you are going to tackle this follow-up? So yeah, obviously this solution will not work on that follow-up. So we need a data structure. For example, if you will see, this scenario will be solvable using queue. So if you use queue and you if you'll apply BFS, then you will be able to handle this follow-up. So instead of like running DFS, I'll start from the leaf node. Initially, I'll push 4, 5, and 3 in the queue itself. Then I'll simply remove the node number 4 and we'll check its parent. Now its parent is 2. This not become the leaf node because 5 is still there. Once we will remove 5 from the queue, you will see uh, you will see the 2 becomes the new leaf node, and we will simply push 2 to the queue. So it's a kind of topological approach. Initially, we will insert all of the leaf nodes to the queue, and every time we will remove one of the node from the queue, the top front node, and we will check the parent, and we will simply insert the parent if that parent is becoming the new node. So that is our other approach you can solve in order to solve a follow-up. So I'm able to think of only a single follow-up here. So yeah, that's it for this problem statement. So I hope you have liked this video. And yeah, and one more thing, you need to write this code pretty fast in actual interview, and you need to divide your time. So just once you have completed your code, you need to try some test cases on your code. Basically, please go through your code once you have completed in actual interview and do some dry run. Basically, you can apply a few of the test cases like edge cases. So basically, you need to complete you need to tell whether your solution is working perfectly or not on each of the scenarios, like a single node or an empty node and whatever. Yeah, so yeah, thanks everyone. Hope you will like this video. Please watch it and do practice well. Also, please like the video and try to share it. And last thing is to uh, subscribe it. Yeah, it will motivate me to make more learning videos. Yeah, so happy learning, guys. And yeah, bye.